Hey Algebra 2 students, today we are going to learn about an application of quadratics called vertical motion. So today we're going to talk about two options, whether we throw an object, meaning it has an initial force behind it, or if we drop an object. Either way, we're going to use this model up here. Let's get my pen going. It looks like this. So that's the model we're going to use. And what we want to do is we want to first just start out by saying, what do each of these variables stand for? So the first one, h, which you can probably guess, is height, but more specifically is height above ground. Okay. And then velocity is v. And remember that velocity can be positive or negative depending on what the scenario is about. Positive meaning we throw something up, or negative meaning we throw something down. T stands for time. And S is for initial height. So what we're going to do is we're going to do some problems using this model up here. And just make sure you're okay. You're also going to want your calculator out because we're going to be solving these using a calculator. So here we go. Our first problem says we jump off a 15-foot diving board with an initial upward velocity of 3 feet per second. How long will it take us to hit the water? So we want to use the model h equals negative 16 t squared plus vt plus s. Okay, so things that we know, we jump off a 15-foot diving board, okay, with an initial upward velocity of 3 feet per second. How long will it take us to hit the water? So the first thing we want to say, well, how high above the ground is the ground? And this right here means when we hit the ground, h would be 0. So we're going to let 0 equal negative 16t squared plus 3t plus 15. Again, remember S is the initial height. So we started at a 15-foot diving board. We had an initial upward velocity of 3 feet, so velocity is positive because we're going up. And then how long does it take to hit the ground? At 0. So we could use the quadratic formula, or we could complete the square. Don't think this is going to factor, but for today we're going to reinforce the idea of graphing. So if we go to our calculator and go to y equals, we're going to type in negative 16. Instead of t, we can just use x squared plus 3x plus 15. And depending on what you did last, you might want to do a zoom and then 6 for standard. And you see right here that the parabola touches the x-axis twice. Okay. And remember, this is a real-life application, so what do we want? Do we want negative time? Well, the answer is probably not. So we have two options here. This one right here is not going to make sense for the context of our problem, but so we want to focus in on this x-intercept right there. So if we want to find where it crosses the x-axis, we're going to go to second and calculate. And we're going to choose 0, which is number 2. And we're going to get this left bound, right bound. And there's my cursor, so enter. Move over to the right, enter, and then enter one more time. And we're going to round to the nearest tenth. So it takes t equals 1.1 seconds for us to hit the water after we jump off the diving board. So, what's the hardest part of this? Well, you already know how to use the calculator, so the hardest part is going to make sure that you read and interpret the problem correctly and get your problem set up. So let's try again. This time we're going to go from the top of a 40-foot cliff. We're going to drop a stone into the water below. How long will it take the stone to hit the water? Well, similar problem. Okay, 40 feet, that's where we start. That would be our S. This time we drop a stone. Dropping a stone means that the velocity is 0. And how long will it take to hit the water? Well, that's the ground, so that's h equals 0. So when I set it up into our model that we're using, it would be 0 equals negative 16 t squared plus 0t plus 40. And if you're thinking, do I need to write 0t? Nope. You could do negative 16t squared plus 40. So we've got our model set up. We go to our calculator, and we can go over here. Actually, just delete some of these. So negative 16x squared plus 40, and then graph it. And again, notice that your parabola, even though you're not seeing the whole thing, that's okay. It looks something like this. Again, a real life scenario, negative time is not going to make sense. So we're just focusing in on that positive time. So we go to second and calculate. We're going to choose 0. And let's find that cursor. Oh, there he is. Make sure we're to the left, then to the right, and hit enter one more time. So we are going to, that stone is going to hit the water after 1.6 seconds. All right. So let's try a couple more together. This one's a little different because this time we're not going to be hitting the ground. We're going to hit something that's off the ground. So I want you to pause and see if you can figure out the model before you see me do it. So go ahead and hit pause and then check with me and see if you're correct. Okay, so let's see if you were picking up on some of the things that I was saying. So when we look through the problem, we throw a marker down from an altitude of 200. That's our initial height. The marker leaves our hand at a velocity of 30 feet per second. Notice my velocity is negative because this right here, we throw a marker down. So if we're throwing something down, that means negative velocity. Okay. And this time, instead of hitting the ground, we want to hit something 10 feet off of the ground. So that final height is 10. So by now you know, in order to use that calculator, we need to be in standard form. So I'm going to subtract 10 from both sides. So my model would be 0 equals negative 16t squared minus 30t plus 190. And then I can go ahead and put it into my calculator. Okay, so I've got it in my calculator. I'm going to go ahead and hit graph. And again, so we're seeing a similar scenario. You've got your vertex way up here at the top, but that's okay. We just do a quick little sketch over here. It's doing something like that. We're only focused on that positive solution because that's going to make sense in the context of our problem. So we second calculate, we choose 0. I'm going to find that cursor, bring him down. Oh, there he was. I'm going to hit enter, arrow to the right, enter, and one more time. That marker is going to hit the ground after 2.6 seconds. Alright, so here we go. We've got one more to do together. Same thing, I would like you to hit pause. I want you to try and get it set up and then check with me. So everybody press pause. Okay, so if we look at the model that I've set up, it says Wolford shoots a ball. It leaves his hand 4 feet. That's the initial height, traveling with a velocity of 30 feet per second. The first question says, how long does it take to hit the rim at 11 feet? A little higher than normal, right? So if you think about what this looks like, here's the basketball. And there's the rim. The basketball's going to go up and then land in there. So here's our initial height of 4. Here's our final height of 11. Okay, so when we graph that, well, we have to set it equal to 0. So negative 16t squared plus 30t minus 7 when we move the 11 over. Let's get that put in here. Change that to plus, change this to minus 7. Delete. And we graph. Oops. Let's try that again. I think I have an extra sign in there. Yep. One more time. Graph. And this time when we look at this graph, notice that we have 2 positive solutions. If I zoom in one time, there they are, 2 positive solutions. You know, what do we think those 2 positive solutions are representing? And if you're thinking it's because this ball goes up, sure enough, it passes that 11-foot mark and then comes back down. So you've got one right here and one right there. So let's go ahead and find both of those points where it crosses that 11-foot mark. So I go to second, calculate, I choose 0. Let's find that cursor. There he is. I'm going to hit enter. And I'm going to hit enter and then enter one more time. Looks like we'll go with 0.3 seconds there. And let's do it one more time. Calculate 0. There it is. Hit enter. One more time. And there we go. So, and we've got one here at 1.6. So the first question is, how long does it take to hit the rim that's 11 feet tall? Well, the answer would be 1.6 seconds, the later time, right? Okay, because it goes up, crosses it, keeps going, comes back in. The second question is, how long is the ball higher than 11 feet? Well, that's from 0.3 seconds to 1.6 seconds, so 1.6 minus 0.3 would be 1.3 seconds. Well, I hope you enjoyed the video. Again, not too much new stuff, just a reminder about vertical motion and how to use your calculator. You've got a few problems from the book to give a try, and I will see you guys back on Monday.